Hello, everyone. My name is Esfand, and I was involved in a number of Innovate UK BPE projects, mainly in the education sector and also a couple of office buildings. So what I present today is based on my experience from Innovate UK projects, but also after reading through the reports, all BPE reports that are in public domain now, and using that data to see whether or not we can come up with some if you like, useful conclusions out of the BPE program. I'll start by exploring a couple of interesting perspectives about the issue of the performance gap. I'm focusing on energy performance gap in non-domestic sector. I'm sure you noticed previous presenters discuss about various factors in terms of the extent of the performance gap. 2.6 times design estimates, somewhere between 2 and 3 times design estimate, so the figure of up to 10 or 11 in one of the presentations. I would like to probe the baseline that we use to determine these factors in terms of the extent of the performance gap, what we call design estimate, to what extent these are really design estimates. And then I move on to the BPE projects, BPE reports, and whether or not we can formulate a way forward, or the way forward basically to procure energy efficient and low carbon buildings in future and in practice. Building services designers are quite familiar with this excerpt from the standard SPEM main calculation output document. So after the inception of the European Directive for Energy Performance of Buildings, the national calculation methodology was developed in this country, and for the purpose of compliance with the building regulations and energy performance certificates, we used SPEM, or dynamic simulation method, to demonstrate compliance and to generate EPCs. It's interesting to note this disclaimer, SPEM outputs. SPEM is not intended as a building design tool. So the underlying principle of this calculation is based on a comparison between the theoretical performance of your building and theoretical performance of the notional building with prescribed building services efficiencies and building fabric characteristics, or a reference building in terms of energy performance certificates. Okay? So it's not about absolute values, it's a comparative analysis. And indeed, I would like to point you to this excerpt from BRE, technical manual for SPEM, in which, if you notice, they tacitly acknowledge the difficulty of projecting absolute performance, absolute carbon emissions or energy performance based on these tools and in this framework. So avoid absolute figures. SPEM is not a design tool. And yet, after a few years, once we have the data coming out of this type of calculation in public domain or available via registers like the Landmark, for example, of course, we were tempted to do such comparison. So all of a sudden, we use the outcome of that calculation as design intent, design estimate, design expectation, and compared it with the actual figure. Okay? And here is the problem of the performance gap. You have two camps. People who developed the regulatory tool and framework to this date are adamant that you shouldn't compare measured performance with the outcome of that calculation. And they have a valid point. People in the energy performance gap camp say it doesn't make sense to use a fictitious, if you like, figure coming out of a thermal model as an indicator of energy efficiency without linking it to measured performance. And they do have a valid point as well. So that's the problem. Okay? The performance gap in this country is a ill-defined problem. The tools and frameworks are not quite there for us to determine the extent of the performance gap with reasonable accuracy. Another example, asset rating or energy performance certificate versus operational rating or display energy certificate. I mean, they look quite similar, but one must avoid comparing these ratings, not least because you're using different baselines. So EPC, as I already explained, is based on a self-reference modeling method, whereas DEC is based on, or the reference point for DEC is based on statistical benchmarking, and it takes into account all loads. It's based on measured performance, and of course, reflects actual operation and impact of human behavior. Whereas in the context of building regulation, we effectively neutralize the impact of human behavior by using default factors for operational schedules, default set points, default equipment load, and so on and so forth. And if you focus on energy efficiency of building services and building fabric accuracy. So as you see, equipment load excluded from EPC rating, included in DEC, and crucially, even fuel CO2 conversion factors are different. So the idea is, so far as asset ratings are concerned, we use the projection of, if you like, future CO2 conversion factor for the national grid, okay? Whereas so far as DEC is concerned, we use the existing conversion factor. And depending on the version of the building regs and the version of EPC, if you like, regulations that we are talking about, you are talking about somewhere in the region of 20 to 30 difference discrepancy between these conversion factors. So it really doesn't make sense to compare these ratings. Having said that, some practitioners in the industry do it, some academics do it, simply because we don't have robust baselines for performance of buildings. So we are trying to figure out whether or not, based on these ratios, the ratio of DEC to EPC, operational rating to asset rating, we can figure out, is it indicative of the performance gap? Well, it is, but there are so many other factors related to these difficulties, and the problems associated with methodologies are also embedded in this type of comparison. I just referred, for example, to the differences in terms of CO2 conversion factors. So one must be very cautious in comparing and trying to establish a relationship or indeed a correlation between these ratings. Just a note in passing, this is what ASHRAE did based on the lessons learned indeed from the EPBD and implementation of the EPBD in various European countries, including EPC and DEX here, and they tried to develop asset rating and operational rating in tandem so that you can compare and contrast, these figures. So they are using the same statistical benchmarking baseline for both systems. They are using the same conversion factors for primary energy and so on and so forth. So that's how it should be done if you want to compare it. But in this country, these certifications were basically developed to respond to various requirements of the EPBD. They were not developed in tandem. They are not entirely consistent. One must be very careful. So there are two main questions at the heart of the problem, or if you like, the debate about the performance gap. One is the question of baseline. The other one is the question of the building context. Every event, every conference or seminar I attended around the question of the performance gap is focused on the building context, how building context affects the performance gap. That's absolutely right. But at the same time, we are using baselines which to a large extent neutralize the impact of building context by using, as I mentioned, standard or default equipment load, occupant density, temperature set points, and so on and so forth. So you can see the tension here. On one hand, we recognize the importance and the impact of building context. On the other hand, to some extent, if not to a large extent, the impact of context is missing actually in these calculations. Before moving to the BP reports, just wanted to briefly refer to another study from North America. Quite like this one, 18 design phase models for LEED Canada certification. And what happened was researchers went back to these buildings and tried to partially calibrate the initial design models by adding the unregulated loads, revising the process loads, weather correction, and so on and so forth. It's not surprising that they managed to reduce the performance gap by reflecting the actual operating conditions to some extent. But what is striking here is in almost all cases, most cases, designers had under-predicted energy performance massively. They are biased to do that for various reasons, not least because on this occasion you can get LEED credits, of course, if you under-predict. I'm not trying to blame designers, but I'm just trying to explain various pressures that designers are basically operating under, these type of pressures. And they have every incentive, if you like, to come up with realistic assumptions, not necessarily the worst case assumptions, to basically come up with plausible energy models and to achieve the credits. The difference between LEED system One of the difference between the LEED system and the regulatory framework in this country, of course, is you have more freedom to play around the equipment load, those settings also related to occupant behavior. And now you can understand why regulators in this country actually opted for default or standardized operating conditions. So there's a good argument for, if you like, for Camp 1, the people who say you shouldn't attempt to compare these. This is like comparing apples with oranges, just avoid it. And they had some good reason to do it. Moving on, nonetheless, I quite like this graph. So I just try to see whether or not we can do the same type of analysis with BPE data. So this is what the BPE, if you like, reports, the final reports trying to achieve. I mean, it doesn't include this graph, but basically they're trying to compare the BER, building emission rate, which comes out of the building regulations compliance calculation with the measured performance. Okay? And this blue line is basically an ideal scenario, which is, of course, non-existent, in which your measured performance would be identical to your calculated performance. Okay? There's no performance gap, just a theoretical line. And then you have your best fit line, which shows the extent of the performance gap. Its slope actually is indicative of average performance gap, and you can compare it to the line of no performance gap. So 2.3, one of the speakers mentioned 2.6. I'm talking about a subset, of that sample, 30 buildings for which I managed to find EPC data from the landmark register. So 2.3, somewhere between 2 and 3 times so-called design estimates is the performance gap if you use BER, building emission rate, which excludes the equipment load, and so on and so forth. Now, what happens if you take into account the allowance for equipment load embedded into calculation to work out heating and cooling loads, use identical fuel CO2 conversion factors, something which was not allowed for, apparently, in the reports that came out of the program, and then you see that measured performance is around 50% higher than the calculated performance. And also, I have to mention that I weather corrected the heating component of energy as well, based on the measurement period for TM22 analysis included in the report. And now you can get a more realistic view of the extent of the performance gap. And I'm not trying to undermine the performance gap, the issues around the performance gap, but I'm just trying to say this is more realistic and more related to technical underlying issues related to performance gap that was uncovered, or were uncovered actually throughout the BPE program. It's important to separate the impact of technical issues from the impact from the other factors related to methodology and differences around methodologies. Now, I worked in the education sector, and I have noticed that there's an interesting phenomenon in terms of schools and seasonal buildings. Basically, the standardized profiles used in the national calculation methodology assume that these buildings are not operational during, say, half-term breaks, for example, school holidays, and so on and so forth. Not anyone who has dealt with schools knows that that's not the case. So far as regulatory calculation is concerned, that's because there are so many uncertainties associated with that type of with building operation outside academic terms, that they just decided to assume the building is not operational and focus on academic terms. Again, the intent was not to project absolute CO2 emissions or energy performance, okay? It was to compare with a notional reference building, that's all. Now, what happens in practice, of course, you have partial operation of these buildings during half-term breaks or whenever a school is not fully open, and you see the problem with the methodology is intertwined with an operational problem whereby building managers, facilities managers tend to condition the whole building. They don't take into account and take advantage of HVAC zoning, for example, okay? Or there are problems around automated control, lighting control. So these problems compound each other, and for that reason, you notice that the extent of the performance gap, the extent of the performance gap in schools and seasonal buildings actually is much higher than the other sectors. We can do the same analysis in terms of heating performance, not CO2, but heating performance and electrical performance. I just skipped through this slide. Just in passing, it's interesting that whenever we compare the heating performance of new buildings with the existing benchmarks, they are usually definitely better than the median benchmarks and very often better than good practice benchmarks. But here, when you compare them with the baseline coming out of the modeling, which takes into account the actual, or if you like, design U values and air tightness, you can see that there's still 40% room for improvement. So it's important to do this type of study. In terms of ventilation strategies, well, it's a big killer in terms of energy performance gap. You can see mechanical ventilation systems performance gap is much higher, or the impact on energy performance gap is much higher than natural ventilation strategy. One must take into account the risk factors associated with mechanical ventilation. Specific fan powers in almost all case studies that I have seen in the BPE program were higher than the design intents, and we had poor system control in terms of demand control ventilation as well. In terms of calculation methods, it's quite interesting comparing DSM with SPEM, dynamic simulation with SPEM. One would expect to get better results, more accurate results if we use DSM with hourly resolution. That's not the case, but that doesn't necessarily tell us which calculation methodology is better, because you usually use DSM for more complex buildings, okay? Larger buildings, complex buildings, buildings that involve various types of building services and thermal mass is part of the design strategy as well. So if you take it as a proxy for building complexity, indeed we see that more complex buildings show more performance gap. The final one, comparison between design and build procurement route and traditional procurement route. It's quite interesting. Most practitioners believe that design and build contracts are among the main drivers for the performance gap, but when you actually see the evidence, when you compare the figures, traditional contracts are not, or traditional projects are not necessarily performing or are not showing lower energy performance gap either. And there's one outlier here in terms of design and build projects is the National Composite Center, for which, of course, the standard equipment load is not really pertinent. If you actually exclude that one from sample, you don't see much difference, statistically significant difference between these two types of contracts. So there are some interesting lessons that could be learned basically from the data that is available in public domain. If this data is merged, is combined with the EPC data, DEC data, and the other data streams that we have. In terms of solutions, as it was discussed by the previous speakers, I couldn't agree more that we really need to move towards performance in use to take into account holistic energy performance and to validate our thermal models with actual performance and to do measurement and verification and allow for a period of soft landings and building fine-tuning after completion so that we can ensure that we can deliver what is anticipated or estimated at design stage. We should be also fair to designers as well. What we call design estimate, so far as the Innovate UK BPE program is concerned, is not really design estimate. One must be very cautious in using these terms and use these figures as design estimates. Thank you very much indeed.
Thank you, Esfand. Next speaker is Marcella Ucci, who is a lecturer in environmental and healthy buildings, who is at IEDE.
Okay, hello everyone. So I'm a lecturer in environmental and healthy buildings, and so today I will be talking about health and well-being against the context of the performance gap. And I've been researching in this field for 10 years and more, and the issue of health and well-being, the keywords have been used a lot more in the last 2 to 3 years. I'm sure many of you have noticed, especially in the built environment industry in the UK, there is a lot more interest, certainly that I have noticed, and we've heard some of the other speakers talking about this too. So what I'd like to talk about is the potential for a performance gap in health and well-being in buildings. And what I see the 3 key gaps that we should try and avoid, and hopefully some of you will also see the parallels with the energy performance gap. So it's a very exciting time for the health and well-being agenda in buildings, but it definitely needs to be channeled in the right way. So first of all, even if we think about the energy performance gap, we could argue that there is an issue with buildings not performing as predicted and the models not being adequate. but also people, okay, not performing as predicted or expected. And by people, I mean the occupants, so-called occupants in the room, but all the other stakeholders involved, and that is the designers, the contractor, the supply, the FMs, the CEO, all the way through to policymakers, so on and so forth. And so I would advocate that actually we have to have a more human-centric approach to understanding the performance gap in building, both in terms of energy and perhaps even more so when it comes to health and well-being. So the first gap that I'd like to talk about is what I'm referring to as expectations. And by that, I also mean the needs, the wants, the habits, the expectations. And there are a number of key questions which I don't think have been completely cracked yet. So one is, can you predict needs and expectations of people in buildings? Should you meet all expectations, actually? Can you change some expectations? And whose expectations should you meet? And the last one is relevant to what I'm also referring to later as the value gap. As an illustration of some of these notions and concepts, I'll give an example related to thermal comfort. So one of the most well-established models to predict thermal comfort in buildings is the PMV model, which is embedded in many leading standards. And so based on this model, we know that if the mean predicted vote is 0, i.e. neutral, which is ideal according to the model, there will be still a percentage of people who will be dissatisfied. The percentage predicted dissatisfied, which is on the y-axis, even when PMV is 0, is 4 to 5%. So actually you cannot please everyone and you cannot meet everyone's expectations. It is a balance to be found, and at the onset, in theory, you have to decide, okay, do you want a category A building with a PPD less than 6% or C like 15%? So that's one thing to consider. If we consider a relatively perhaps easy example, a low-hanging fruit of saving energy and without, negatively affecting thermal comfort, is the idea of raising thermostat settings in buildings. So one of my PhD students has been looking into this idea: can we raise the cooling set point of UK office buildings air-conditioned to 24 degrees following the BCO recommendation? And now this was based on a report from Arup, and in turn all of the studies in this field, I should say, are based on observational data. So they're asking people, how do you feel now? What temperature do you prefer now or, in the past week? But they don't take into account the impact of habits and expectation. If I change the temperature to what the mean value that other people prefer, will you still be satisfied? She's done a number of intervention studies, and one of the things that we knew, but perhaps we didn't anticipate the extent of it, was that the HVAC systems are incredibly not sufficiently predictable or responsive. So, we were trying to do a case control study of one floor remaining at certain temperature and the other you change the thermostat setting on another floor. Well, you can forget it, because actually the control floor was constantly at higher temperature even after the intervention. And there were incredible variations in temperatures across the floors and between the floors. The FM manager ended up reacting to isolated complaints. So even though the majority of people were satisfied, at the end there might have been 1 or 2 complaints. So sometimes it's people who shout the loudest who are heard. And so it's actually quite difficult for facility managers to manage that level of complexity. And incidentally, sometimes they had to call the BMS contractor to change the thermostat settings. And so even that is not that easy. And so really, expectations and habits play a very important role. More broadly, actually, is neutral thermal comfort always desirable? There are some leading academics in this field which are now praising the value of variations in temperature in terms of space and time. Also, there has been some findings that there is an association between lower ambient temperatures and lower prevalence of obesity. This might be due to the role of the brown adipose tissue. And even cold exposures may be beneficial to people suffering with diabetes. So it's kind of questioning the idea, should we always be kept at an ideal neutral thermal comfort? So should we always give people what they think they want? So the second gap is the one about value. And by value, I mean there is a disconnect between potentially who has to deliver healthy buildings and those who benefit from it. And that could be, let's say, the NHS or the individual occupants, but also the meanings. What the various stakeholders actually mean by health and well-being is very diverse across the chain. And, you know, really the stakeholders in the chain don't necessarily understand each other. Let's remind ourselves of the determinants of health and well-being in people. So you have at the individual level your all individual factor, the hereditary factors, the lifestyle. Then you have the impact of the physical environment, the social environment, the economic environment, and the finances and the policy environment. So actually it's a very, very complex system, and we need to consider all of that. If we consider the definition of the WHO of health, is a very encompassing one, and rightly so. However, in practice, there are different stakeholders on the ground that are more concerned with some aspects compared to some others. And so if we define and consider the health as in ill health, i.e. those that can be, let's say, one way or the other diagnosed and has an impact on the NHS, on the public health, then immediately you have more of the interest of people working in public health, epidemiologists and public health researchers and policymakers. On the other hand, if you conceptualize health and well-being in terms of safety, comfort, and satisfaction with the indoor environment, perhaps there is a more direct interest from designers, facility managers, all the way to policymakers, building regulations. And for example, the BUS methodology and even the self-reported health in the BUS methodology would be absolutely meaningless to the people on the top end who talk about ill health. I think we would be laughed out of the room if we talk about some of those aspects. If we consider human performance and productivity, for example, then there are other parties involved, like the employers and the HR. If it's a school, then you would have the teachers and so on and so forth, and the policymakers. And finally, if you conceptualize well-being as happiness and fulfillment, then you can imagine there is a lot more stakeholders at the individual, community, societal level, and policy level. So just to give you an example of the disconnect across the stakeholders, this is a survey done in the US of public health practitioners, general practitioner, pediatrician, and psychologists. They were asked the question, do you believe that buildings impact upon patient health? And the blue is yes, and the burgundy is no. So already we have, you know, quite an important gap in perception of the importance of the environment. And this is really quite poignant even in the UK. There are some now attempts to try and kind of bridge the gap, close the gaps across the various stakeholders. This is a report produced by the NHS Alliance and funded by DCLG, which tries to kind of explain in a way to housing providers and managers what sort of things really matters to clinical commissioning groups. And this is against the context of the devolved responsibilities of public health to the local authorities. So there are some tiny steps being made, but the gaps actually across stakeholders are really still quite wide. And really the value gaps is important with respect to at the macro and at the micro level. So I think behavior is really extremely important. For those of you who are familiar with the well-building standard, this is something that's been really acknowledged in that standard. And the behavior is not just the behavior of the individuals, but also is the behavior of the organizations which manage the building. And really, this is something that is extremely challenging if you are not considering the case of a building which is being commissioned by an owner-occupier, but by a building that is built for speculative purposes. What is the business case for healthy buildings? So we, you know, in some circles there is a lot of discussions around this. Should building developers pay for the societal benefits of healthy buildings? And are health and well-being benefits for the employee and the employer always aligned? So, you know, the CEO might actually not care that much that 90% of the workforce is thermally comfortable. They might want to know, well, what's the bottom line? You know, what does it mean in terms of productivity, for example? And unfortunately, there isn't that much solid data around there. The policy levers is also another gap. For example, in England, there is no one government department or agency who is responsible for health and well-being in the indoor environment. And also there is a certain reluctance to try and change the behavior of people in the home. Evidence gap is just too much, I can't talk about it a lot, but let's remind ourselves again, you know, actually the health outcomes are affected by all sorts of aspects, the genetic factors, physical and social environments, behavior, and so on and so forth. So actually the amount of data that is needed to prove an effect is quite vast. Unfortunately, within this field, there is a lack of data, especially regarding indoor exposures. It's a lot easier and cheaper to stick for example, a monitor of indoor air quality in a street. It's a lot more difficult and complicated and expensive to monitor indoor air quality in people's homes or even in individual buildings. And so, in a sense, there is a little bit of a vicious circle at the moment because there isn't enough of the type of evidence that public health professionals need to actually prove that there is a link between some aspects of the indoor environment and health and well-being. Because of the lack of evidence, there isn't enough action, and so on and so forth. But really, the message here is that large-scale studies are needed, large field-scale studies are needed, and I do wonder whether perhaps data sharing may be an option, because even if we are studying, you know, 1 or 2 housing estates or 1 or 2 large commercial buildings, we may not achieve the sort of sizes that are required to detect some of these effects. So in terms of you know, the key points for bridging and closing the gaps, we really need to focus on gathering the evidence, not only the academic evidence, but also the evidence that is meaningful to stakeholders, and especially focus on the evidence that can help bridge the gaps across what the various stakeholders really mean by health, how do they measure it, and how they value it. And I wonder, you know, this agenda is actually very, very intertwined with the energy agenda because, of course, you know, there is, for example, a balance to be made between ventilation and energy. And perhaps there is some lessons to be learned from the building performance initiatives on the energy side to try and avoid some of the pitfalls. But one of the other things to mention is that, for example, CO2 by itself is only, in most cases, is a proxy of indoor air quality, so we should really extend the monitoring there. And self-reported health doesn't always work for, let's say, the academics in the field. I'd like to finish by mentioning a few initiatives that are relevant to this, in which I'm involved, and IEDE is involved. So the first one is, as Mike mentioned earlier, the MSc in Health, Wellbeing and Sustainable Buildings. So this is going through the UCL approval stage at the moment, and hopefully after approval it will be launched in September 2017. We are very keen to form a really new generation of built environment professionals who are really able to understand the different points of view of the various stakeholders and really work with the principles of integrated design and systems thinking. We're keen also to find industry partners who will give us real projects so that our students, as Rod was saying, really apply these, understand these on the ground, what the key issues are. Also, I'm chair of the UK Indoor Environments Group, which is a free membership organization. And amongst various things, we are organizing a number of workshops. So we've obtained funding by the Gas Safety Trust to run a policy workshop to try and understand some aspects of indoor environments, health and well-being. And at the moment, we're looking for partners for running a series of workshops with other key stakeholders, with, for example, housing providers, designers, public health professionals, and so on and so forth. Finally, I think behavior and psychology is very important. Perhaps is not studied and used as much as we should do is in this field. I'm an affiliate of the UCL Center for Behavior Change, and I would really like to think that we need to understand behavior a lot more. Thank you.
Thank you very much, Marcella. And so for the third presentation in this session, very pleased to welcome Stacey Temprell, Sector Marketing Director for New Build for Saint-Gobain.
Tiptoes. Good afternoon, everybody. So I'm going to give a little bit of a different view, not obviously coming from the academic sort of fraternity. So I'm representing industry, and woe betide me, that group of manufacturers, where we all huddle together and share our secret data, as Rob Pannell spoke about this morning, just to give you a view as to some of the developments that we're making in response to sort of what's being asked of industry. It's not just government, not just academia, but industry. And so I want to just spend a few moments talking to you about our campaign, which is My Comfort by Saint-Gobain, which is a new standard for multi-comfort buildings. Why we've done this, our aim as Saint-Gobain is to create great spaces, in terms of great spaces for living, obviously. That's what's driven us to launch the multi-comfort building concept. And I stress that we've launched this as a concept, which we launched at EcoBuild last year, and we're now in development and testing phases, and that's what I want to share with you today. So what multi-comfort buildings are, they incorporate passive house design, but it's a way of designing and building sustainable, comfortable and healthy home and work environments. So following on from the ethos that Dr. Ucci has just been sharing with us. Why we've done it? Well, as we know as humans now, we typically only spend about 10% of our time outside. So we are spending 90% of our time either inside buildings or in our vehicles. So this means that the buildings where we are spending our time, whether we like it or not, are having a significant impact on our comfort, health and well-being. So from our perspective, from a Saint-Gobain perspective, we started looking at this a number of years ago from a research and development perspective. But from how we kind of thought other manufacturers were looking at developing solutions, we started to look at it in terms of ask what if from the other end of the spectrum. So what if, rather than just talking about minimising negative impacts of building solutions both on the environment and on people, we look at how buildings can actually be designed and constructed to have the most positive impact on both people and the environment. And that's what's driven us in our work for developing the multi-comfort standard. So by carefully considering the different areas of comfort that a building can provide, we're able to improve people's well-being within the building. And this is limited to the building and the building fabric and the confines, if you like, of the building. So we believe that by different areas of comfort, which we've divided into thermal, audio, visual, indoor air, but also economic, are all equally important when looking at comfort in a building and providing health and well-being. In terms of our credentials as Saint-Gobain, we're 350 years old as an organisation, but probably one of the industry's best kept secrets. When I come on to the brands that are part of Saint-Gobain, you'll be more familiar with those, I'm sure, in a moment. But in addition to our sort of global presence here in the UK, we have 400,000 products from 40 different businesses, 16,000 people based in the UK. We have a large international R&D presence, so 3,700 people employed across the globe just in R&D, with a significant spend and a significant patent track record, but all with a view of obviously driving this sort of constant funnel of improvement of products to improve the built environment performance. But we have experts across the field from building physics, acoustics, air quality, daylighting, thermal performance, fire safety, and it's actually bringing these people together under the multi-comfort banner has actually driven us to come up with the multi-comfort building standard. So there is a introduction book to the multi-comfort building standard in your packs, and you can see this criteria on pages 38 and 39 of said book. Dr. Ucci sort of referred to the WELL standard a few moments ago. So the multi-comfort standard, it gives you a set of design criteria. So it's not as onerous or as restrictive, if you like, for the designer. But we believe that these criteria are infinitely doable in so much as it's buildable, it's achievable, and most importantly, these criteria, these measures can actually be achieved without conflicting. The pH that you see here in the margin, particularly there relating to the thermal comfort parameters as outlined, are where the standard obviously aligns with Passive House. As Saint-Gobain worldwide, we are members of the Passive House Institute and obviously founder members here in the UK, and obviously this is grounded in Passive House theory. But it's looking at introducing measures that are infinitely measurable across those other areas of comfort, so taking into account audio, visual, indoor air, and also economic. So we didn't want to release a standard that didn't actually address the cost factor, because obviously this is about sort of stimulating some test and stimulating some debate in the industry, and obviously cost has to be up there as well. So in terms of what multi-comfort buildings are designed for, obviously they are designed to be able to keep themselves warm using very little energy, obviously without the need for radiators or any other underfloor wet heating systems. Obviously to save people money to spend on what they like. Saint-Gobain, many other construction manufacturers in the UK have been talking energy efficiency to the market, Green Deal and everything we've spoken about earlier today, and I think it's sort of fairly widely acknowledged that as a motivational factor for general consumers, energy efficiency doesn't really hit the spot. Also from a thermal comfort perspective, multi-comfort buildings mean there's going to be no drafts even on the floor, keeps your ideal indoor temperature all year round, and every wall is warm to the touch. Lots of user feedback that we get is around the fact that sort of buildings have particular sort of cold spots and areas that can't be used, and obviously with property prices increasing and typical sort of new builds getting smaller, every available space is obviously crucially important. From an audio comfort perspective, multi-comfort buildings mean you can't hear the neighbours if you're an attached dwelling, but you can make noise without disturbing others, so you're free to use the space in the way that you'd like, and also protects you from the noise outside. But also, just as importantly, in terms of audio comfort within a room, particularly when it comes to non-residential buildings, multi-comfort buildings ensure that the sounds you want to hear are crystal clear, means that you can hear perfectly anywhere in the room, and nowhere is that more important than in schools. And also where you're not going to be distracted by background noise. We've spoken earlier a lot about sort of schools, for example, as one type of non-residential building that aren't just used for schooling of children. They can be used in lots of other ways, and in terms of a service building for that community. And so there's lots of activities typically going on in buildings that we don't want to be disturbing other activities. From a visual comfort perspective, multi-comfort buildings are full of natural light without glare. Bring the outdoors inside, making you feel good in terms of that connection with the outdoor environment. And obviously that also means that close-up work is easy and colours are going to be rich. You're going to get true representation in terms of the space within inside the building. And from an indoor air comfort perspective, they keep outdoor pollution outside. They actively purify the air in terms of VOCs, controlling moisture and therefore odours. Again, a big issue in buildings of discomfort. And a constant supply of fresh air means obviously that rooms won't feel stuffy, keeping people feeling alert all day. And then from an economic comfort perspective, multi-comfort buildings obviously won't have the worry of high energy bills. They need a lot less maintenance than typical buildings. And they won't cost the earth to build nor the environment in terms of what's actually put into the standard as well in terms of the whole life approach, design approach, as well as costing. And in terms of what we would expect them to deliver, and at this point it is expect in terms of a home environment, people have better sleep, reduced stress, improved health. From a health building perspective, faster healing, reduced bedtime, happier staff. From an office perspective, improved productivity, reduced absenteeism, increased job satisfaction. And from an education building perspective, improved concentration, better communication, and ultimately higher test results. And so, as I said, we've launched this as a concept, and now we're into testing phase. So the first multi-comfort building will be complete at the end of this month, and be handed over back to the client. So it's the King's School in Worcester. So we've worked on this with Speller Metcalfe as contractors, Associated Architects as the architect. And obviously it's quite different in terms of a typical sort of passive house-looking buildings. Obviously, it's needed to fit with the Worcester sort of barn vernacular, and we've managed to achieve it with a new system, which is giving us overall significantly thinner construction than what has been typically done before. And this is being tested and verified. So this is a new multi-purpose school hall. So it's used for sports, it's used for drama, it's used for assemblies, it's used for productions. And obviously there is an old school hall, so we've been monitoring that for almost a year, both from a quantitative perspective for all of the areas of comfort in terms of the quantitative measures that I've outlined. But for us, more importantly, from a qualitative perspective, so what does it feel like being in that building at the minute? And obviously, it's some of the things that are not necessarily measurable in the usual way, but the qualitative data that really makes people's experience come to life. So the fact that in the old school hall, you have obviously people needing to keep their coats on for all of assemblies. If you're going in for parents' evening at the school, nobody takes their coat off the whole time because the building is so cold. Conversely, in the summer, everybody's very early for school. Everybody's early for assemblies because everyone wants to be able to sit by the door where there's actually going to be a breeze so that you don't actually pass out halfway through. The children don't like doing games in there when they've got to take their shoes off because they do gym bare feet, for example, and don't like being on the floor because it's cold. And it's all these sorts of things which are really sort of combining to give us much more evidence in terms of my comfort. What do people value? What do people find comfortable in buildings? We're also testing in terms of, rather than a new build non-domestic perspective, we're also concurrently doing a renovation, so a 4-bed masonry empty home, so showing that a home can also be renovated to MultiComfort standard. So this is on the university campus in Nottingham, but obviously it's a commercial building that's rented out. And this has actually been done in conjunction this year with the 120 engineering and architectural students of University of Nottingham, and it's those students that are working on the designs for the MultiComfort building. So obviously we've been training them, if you like, in terms of what a MultiComfort building is. And again, this one starts on site this month, and obviously will complete at the end of June because the students are actually going to be hands-on alongside the contractors in terms of looking at how this is actually renovated. Obviously, this is done using the majority of Saint-Gobain products and systems. And this is where, from a Saint-Gobain perspective, our products and solutions for industry encompass sort of these brands. So apart from the main frame, whether you choose to do a building in masonry or timber frame or steel construction, Saint-Gobain have the products and solutions that pretty much can finish the building from the outside in. And so it puts us in a unique position to be able to start testing solutions in a much more holistic way to actually try and eliminate a lot of the issues where issues in the performance gap typically arise. And then obviously when they team that with our breadth and depth of network in terms of the brands of Saint-Gobain, in terms of touch points for the industry through our distribution network, we're well placed to get feedback on what people are finding in terms of issues in buildings and then developing the solutions to try and correct some of those areas. In terms of products and solutions from the group, I'd say these are many and varied through thermal comfort, audio comfort, visual and indoor air. And from an economic perspective, yep, we're saying that, okay, it's likely there's still going to be some upfront material cost increase over building to standard regulations, but obviously we would expect that the decrease is going to be many times over in terms of running costs. And on both of those reference builds that we're doing, not only are they being independently verified as meeting MultiComfort via Warm Associates, all of the quantitative and qualitative monitoring we have partnered with BRE over a 2-year period to do, but also then Gleeds are actually doing all of the finances to actually be able to give an independent view as to what the cost of a MultiComfort building is. We've also developed a course which we've started running from the Saint-Gobain Technical Academy networks. We found there was lots of courses out there for designers of sort of particularly passive house buildings, but not much was actually out there for contractors to actually learn how to build a passive house level. So we've actually launched that course and we've got great uptake on that through the academies, really sort of showing that there is this growing demand for higher performance buildings and contractors are more and more willing to actually come onto the courses to actually learn what they need to do to close the gap. And I think the link here with wellness obviously is a key one. You know, it's key from a marketing perspective to always look at the trends in other sectors. And if we look at the global market for wearable devices, this went from you know, so Fitbits and the like, if you will. So from a market that didn't exist in 2010, we expect it's going to be 150 million units sold annually by 2019. So people are inherently becoming more interested in their health and well-being because they're getting the tools to be able to measure it. And so it's not beyond the wit of man that how this is actually extending from measuring what's going on for yourself in terms of what's going on to your building. And we know that a lot of this is happening already in terms of small devices, looking at air quality in the external environment, to also now lots of different sensors starting to come out in terms of for people to actually start to measure their own indoor environment with a view to measuring one against the other, seeing how good or bad it is, and looking at what improvements can be made. With the Internet of Things now, obviously people are sharing that data, and obviously that's becoming increasingly important, particularly for people in rented accommodation, where they're looking to share the performance of buildings. And also the development, lots of people sharing their sharing their feelings as well as to sort of, what buildings are actually making them feel like. And so I think in terms of how these, all of these different factors are going to collide in the future is going to give building users a lot more information at their fingertips that they can use. And when people have more information, typically they're going to demand more solutions. And we fully expect that the next smartphones, in terms of what we believe, will actually have the sensors in, so you won't even have to part with £500 for a cube sensor, in terms of it will be on the next iPhone 7. That's it. Thank you very much. That's an introduction to MultiComfort.